Before starting this lecture, I will suggest everyone to see my previous video where I have discussed about the equation of straight lines on a complex plane, its complex slope, and area of the triangle and its allied properties. So if you are not comfortable with those formulae, you won't be able to understand what I am doing here, because here I will simply use those formulae and we will solve problems. Here I am not going to discuss any theory regarding that. So before starting this video, I will suggest everyone to see my previous video. The link has been given in the description box. Please check it, see that video, and then come for this video, which will deal with the problems of that previous video. Okay, so let us start this lecture with this sum. See this problem, it's a wonderful one on the context of whatever we have learned so far in this video. Two different non-parallel lines meet the circle mod z equals to r. At the points a, b, it should be and C, D respectively. Prove that these lines meet in a point Z given by, we have to prove that this point is nothing but this one. There is a circle whose center is at the origin. The equation of this circle is mod Z equals to R. And there are two non-parallel lines. These are two non-parallel lines meeting the circle at A, B, C and D, and these two lines are meeting at a point Z. So we have to find out that this point is nothing but this. This is the question. Now A, B, C, D, these are all complex numbers. We are all dealing with the complex plane. So A, B, C, D, Z, these are all complex numbers on the complex plane itself. Now you see, since the point A is on the circle A, B, C, D, therefore we can say that mod of A must be equals to R, implies mod A square is R square. That implies A bar will be equals to R square. So from here we can write that A bar is nothing but R square by A. Correct? Similarly, we can find out B bar is R square by B, C bar is R square by C, and D bar is R square by D. Is it okay? Right? Now, look it carefully. The point A, B and Z, they are collinear. Since they are collinear, so we can say that determinant Z bar 1, A bar 1 and B bar 1, this must be equals to 0. Now if I open the determinant, if I expand the determinant, what we are going to have? Simply I am expanding the determinant with respect to the first row. Since in the answer there is no bar, so we have to remove those bars given over here. That is, the conjugate of this complex number should be removed, because in the answer I don't need any conjugate of any complex number, right? So my main task is to remove those conjugates with the help of the equations that we got. So what we can write? This A bar can be replaced by B bar replaced by R square by B. No need to change this one. Again, B bar is replaced by R square by B, and A bar is replaced by R square by A equals to 0. Okay. So I can take R square common and we can divide it, because R is not equals to 0. It is not a point circle such that the radius is 0. No. So I can divide it by R square. So what we are going to have? Tell me yes or no. Let me simplify. Okay, so if I open this one, we are going to have is it fine? Now, since A is not equals to B, these 2 points are not the same point. They are the distinct points. So I can divide both sides by B minus A. Is it clear? So we got this relation from these 3 points A, B and Z. Fine. Now if I apply the same method for the points C, D and Z, then we are going to have the same equation. In place of A, B, C, D will be replaced. So in that case we will write it is Z by CD plus Z bar by R square minus C plus D by CD equals to 0. Tell me yes or no. Now in the answer, actually we need this Z. This Z. We don't need this Z bar and R square. It's a foreign element to us. So we have to eliminate this, and for that I'm simply subtracting this second equation from the first one. So we are having is it clear? So we are getting what? No need to simplify this. No need to simplify this because we will directly get the answer from here. So your Z will become A plus B by AB means it's 1 by B plus 1 by A. C plus D by CD means it's 1 by D minus 1 by D plus 1 by C. Because a minus sign is there, so it will be 1 by D minus 1 by C, right? Divided by, this is what? A to the power minus 1, B to the power minus 1, minus C to the power minus 1, D to the power minus 1. Have you got it? Because this part will come in the denominator. So in the denominator, it will be 1 by AB minus 1 by CD. So it is same as A to the power minus 1, B to the power minus 1, minus C to the power minus 1, D to the power minus 1. So in the numerator, we are having A to the power minus 1 plus B to the power minus 1 minus C to the power minus 1 minus D to the power minus 1 divided by A to the power minus 1, B to the power minus 1 minus C to the power minus 1, D to the power minus 1. And that is what? That is nothing but your Z. Z is what? Z is the point of intersection of these two straight lines. And that exactly what they have said to prove. They have said that prove that the point of intersection, that is Z, is nothing but this one. And that exactly what we have proved over here. Is it fine with you? Absolutely. Let us take a same type of sum with a different flavor. Two different non-parallel lines meet the circle mod Z equals to R, one of them at points A and B, and the other which is tangent to the circle at C. Show that the point of intersection of two lines is given by this one. Let me draw the circle whose equation is mod Z equals to R. Now they have said that there are two non-parallel lines. One line is meeting the circle at A and B, and the other line is tangent to the circle at C. This is the center O. And this is the point of intersection of these two straight lines. Let this point of intersection be Z. Okay. So now you have to prove that Z is nothing but this one. This is the question. Now as A, B and C are all lying on the circle, therefore we must say that mod A is R, implies the same thing that we have done in the previous sum. So A bar will be equals to R square. So A bar can be written as R square by A. Clear? Similarly, B bar can be written as R square by B. And C bar can be written as R square by C. Right? Now, A, B and Z, these 3 points are collinear. Therefore, we can say that the determinant this will be equals to 0. Now, if I expand the determinant with respect to the first row, we are going to have okay, let me replace A bar, B bar by the conditions that we got. So we are having let me divide both sides by R square, as R cannot be equals to 0 because it is not a point circle, as I have mentioned in the previous sum also. So if I simplify, now if I divide both sides by B minus A, we are having is it clear? So we got this equation, right, from the first these 3 points when they are collinear by using that condition. Now you observe CZ, this is a tangent to this circle. So if I draw a perpendicular on the tangent, it will intersect at the point of contact, which is C. Let me just join OZ. So this is 90 degree. If we apply Pythagoras theorem, it will be what? OZ square equals to OC square plus CZ square. OZ square is what? It is mod Z square equals to OC square is nothing but the radius. So it's R square plus CZ. It is mod of Z minus C whole square. So it can be written as mod Z square, or else you can write in this way. Mod Z square can be written as ZZ bar equals to R square plus Z minus C into Z bar minus C bar. Let me open the brackets. Simple multiplication. Clear? Now, C bar. C bar is nothing but mod C square, and mod C square is nothing but R square. So this one will give you what? 2R square. This and this will go off. So in the left hand side, if I take CZ bar and C bar Z, this will be plus. Is it fine? Now, let me divide both sides by R square. So we are having CZ bar by R square plus C bar Z by R square equals to 2. Now, this R square can be replaced by, you see, C square is nothing but R square, right? Which is nothing but your CC bar. Okay. So, if I replace this, what we are going to have? CZ bar by R square plus C bar Z. This R square, I am replacing it by CC bar equals to 2. Okay. So, we are having what? Z bar by R square plus Z by C square equals to 2 by C. I am dividing both sides by C also. Till this, is it clear to all of you? Okay. Now, you see, I can replace this Z bar by R square Z by R square will be what? Let me write it here. What will be Z bar by R square? This is nothing but 2 by C minus Z by C square. Now let me take this value of Z by R square and replace it in this equation. So what we are getting? So we will get Z by AB plus this Z bar by R square is replaced by this one. So 2 by C minus Z by C square minus A plus B by AB equals to 0. Correct? Now let me remove this paper. So from here we are getting, if I take Z common, it will be 1 by AB minus 1 by C square, which is equals to A plus B by AB minus 2 by C. So we are having Z A to the power minus 1, B to the power minus 1 minus C to the power minus 2 equals to A to the power minus 1 plus B to the power minus 1 minus 2 C to the power minus 1. Is it clear? So if I divide, so Z will be A to the power minus 1 plus B to the power minus 1 minus 2 C to the power minus 1 divided by A to the power minus 1 B to the power minus 1 minus C to the power minus 2. And let me take minus common. So in the numerator we are left with this thing, and in the denominator we are left with this one, right? And that is nothing but your Z. That exactly what they have said to prove in the question. Look it carefully. They have said to prove that the point of intersection is nothing but 2C to the power minus 1 minus A to the power minus 1 minus B to the power minus 1 divided by C to the power minus 2 minus A to the power minus 1 B to the power minus 1. That exactly what we got here. Is it clear? Absolutely fine. Okay. Now, let me take another problem. See this problem. Show that the point A dash is the reflection of the point A with respect to the line, this one, if A dash B bar plus A bar B plus C equals to 0. This we have to prove. Now, I will suggest to pause the video right here and try this sum by your own. If you cannot solve it, come back and see the solution. Okay. Now you see, the equation of this line is ZB bar plus Z bar B plus C equals to 0. A point A is there, and the reflection of this point with respect to this line is A dash. So this point where the line joining A dash with this line will be the midpoint of these 2 points. Therefore, this point is nothing but A plus A dash divided by 2 by using the midpoint formula. Okay. Now, this point is lying very much within this straight line. Hence, it must satisfy this. Is this okay? So, I can write this thing as this one I have written, A bar B, this one I have written, and I have written 1C. So the extra term I am writing in this bracket, it is AB bar plus A bar of dash, A dash bar B plus C. These are the extra terms that we have, right? So this much we got from this relation. Now observe carefully, the complex slope of this line is nothing but minus B by B bar. And what is the complex slope of this line joining A dash? Is nothing but A minus A dash divided by A bar minus A dash bar, right? Since they are perpendicular to each other, therefore we can say that this must be equals to 0. because we know that when two lines are perpendicular to each other, the sum of their complex slopes is equals to 0. So what we are having basically? That implies so we can write this thing as is it clear? So in place of this, I can replace it with this one. So this part can be replaced by this one. Therefore, this equation becomes is it okay? So that implies what? 2 times. That implies what? Is it clear? Therefore, this is the relation which we have to prove, which is given in our question, has been proved. Is it clear? Therefore, A dash will be the reflection of the point A with respect to this line when this condition holds true, and that is proved. Is it clear? Let us take a last problem for this session. See this problem. It's a very, very challenging sum. Let ABC be the coordinates of the vertices ABC of a triangle. It is known that mod A equals to mod B equals to mod C equals to 1. And there exists an angle alpha which lies between 0 and pi by 2 such that A plus B cos alpha plus C sin alpha is 0. Now we have to prove that the area of the triangle ABC lies between 1 and 1 plus root 2 by 2. Is it clear? Now, how to approach this sum? How to do this sum? We have been given that A plus B cos alpha plus C sin alpha equals to 0. So from here we can write that B cos alpha plus C sin this is alpha. This is alpha equals to minus A. Clear? Now again I am telling you this ABC are the points associated with the complex numbers on the complex plane. So in that case, if I take mod on both sides, what we are going to have? Which is nothing but your mod of A, which is nothing but your 1. So if I expand this, let me take square on both sides. So this one will be 1 square. So this can be written as B cos alpha plus C sin alpha into B bar cos alpha plus C bar sin alpha, right? Which is equals to 1. Let me open this. Now, B bar, this is what? This is actually mod B square. Now, they have already given that mod A equals to mod B equals to mod C equals to 1. Therefore, mod B square will be equals to 1 only. So, in that case, what we will write, it is cos square alpha plus B bar C plus BC bar sin alpha cos alpha plus, this is again CC bar. CC bar means mod C square, which is again equals to what? According to the given condition. So this is again sin square alpha, that is 1. Now cos square alpha plus sin square alpha is 1. That 1 will get cancelled with the 1 in the right hand side. So we are having B bar C plus BC bar sin alpha cos alpha, which is equals to 0. Now, as alpha is lying between 0 and pi by 2, therefore neither your sin alpha nor your cos alpha is equals to 0. This is not equals to 0, right? Therefore, the only option left is B bar C plus BC bar equals to 0. Yes or no? So this is the relation that we got. Okay. Now this can also be written as, if I multiply BC on both sides, so we are having, actually, if I open the brackets, we are going to have B bar C square plus B square C bar, which is equals to 0. So that implies this is mod B square C square plus mod C square B square, which is equals to 0. Now again, according to the given condition, all values of mod B square and mod C square equals to 1. So from here we are getting C square plus B square equals to 0, implies B square is minus C square. That implies B is nothing but plus minus iota C. Yes or no? Yes or no? So we got this relation, B is nothing but plus minus iota C. Okay. Now we have to concentrate on area of the triangle ABC. What we have learned for the area of triangle ABC? Area of triangle ABC will be equals to half imaginary part of A bar B, B bar C, C bar A. It's a cyclic one. I taught you this. So now you see I got the relation between B and C. So I don't need A over here. So I will replace this A from this expression. How? With the help of the given condition this. With this one. Yes or no? With this one I will remove this A bar and A. Look it carefully. Let me write it here. B cos alpha plus C sin alpha. We are having this thing as minus A. Okay. Now, so I can write this thing as half imaginary part of A bar. What is A bar? A bar is nothing but, B is there. A bar is nothing but minus B bar cos alpha minus C bar sin alpha, correct? B bar C, it will not create any problem, so I'm writing B bar C, and C bar A, again C bar, this A I'm replacing it by minus B cos alpha minus C sin alpha. Am I correct? So let me close the bracket over here. Now, half imaginary part of, let me just multiply. So what we are going to have, here we are going to have minus B bar, which is nothing but mod B square, which is 1. So this is only cos alpha. This is BC bar sin alpha plus B bar C is there. If I open the bracket, this one we are going to have minus BC bar cos alpha minus again C bar, which is nothing but your mod C square, which is 1. So we are left with only sin alpha over here, correct? So this gives us half imaginary, but it is simply, I'm simplifying this expression, nothing else. No complexity is involved in this part. So minus sin alpha plus cos alpha plus B bar C minus BC bar, this is sin alpha plus cos alpha. Here we are only concerned about the imaginary part. This is absolutely a purely real one, so which does not contribute anything in the imaginary part. So I can remove this one directly. So this is half imaginary part of B bar C minus BC bar sin alpha plus cos alpha, correct? Now, you see, I got here B bar C plus BC bar is 0. So, BC bar can be replaced by minus B bar C. Let me replace it. Yes or no? Tell me yes or no. Because we have B bar C plus BC bar equals to 0. That we have already proved. So now we can write half imaginary part of B bar C 1 plus sin alpha plus cos alpha. Okay. Now I can take this one. This is a purely real one. So I can take this thing outside the imaginary sign. So we can write this thing as half 1 plus sin alpha plus cos alpha imaginary part of B bar C only. Have you got this one? Because if I ask you, what is the imaginary part of A, say Z, okay, A is purely real. So I can take this, because this A, I can take it outside. So it will be A imaginary part of Z only. Are you getting my point? Otherwise, if you want to explain me, let me just explain this. Let us say Z is X plus iota Y. So this is what? Imaginary part of AX plus iota AY. So imaginary part of this complex number is only AY. Tell me yes or no. Now what about this? Imaginary part of Z is what? Y. So ultimately in this case also you are getting AY. Is it clear? That is why I can take this purely real one outside the imaginary part. So that's exactly what I have done. So what we got? Area of triangle ABC is nothing but half 1 plus sine alpha plus cos alpha, imaginary part of B bar C. B bar C. Now we have already got that B is nothing but plus minus iota C. Let me write it here. Let me remove this paper. If needed, I will bring it back. So here we got that B is nothing but plus minus iota C, right? So let me just replace it. So what will be your B bar? It will be minus plus iota C bar. Yes? So let me write it here. Half 1 plus sine alpha plus cos alpha, imaginary part of minus plus iota C bar. Again, C bar is mod of C squared, which gives you 1 only. So it is half 1 plus sine alpha plus cos alpha. This is imaginary part of minus plus iota. Yes? Yes or no? Now one thing you must remember, we are finding out the area of the triangle ABC. Therefore, the area of the triangle is always with a mod sign. So, if we put a mod sign, you observe carefully, this thing will simply come out of the mod sign. Why you know? Because your alpha is lying between 0 and pi by 2. So, where sine alpha as well as cos alpha are positive. So, this whole part is positive. So, I am taking it outside the mod sign. So, now this is imaginary part of minus plus iota. Right, with a mod sign. Now, imaginary part of minus plus iota is basically minus plus 1, because that is the imaginary part of this complex number. Yeah. So either it will be minus 1 or it will be plus 1. But since there is a mod sign, so only 1 will come out. Therefore, the area of the triangle ABC becomes 1 plus sine alpha plus cos alpha. Tell me yes or no. Alpha is lying between 0 and pi by 2. Observe it very carefully. So, area of triangle ABC can be written as half, little manipulation, 1 plus, if I write root 2 over here, then it will be 1 by root 2 sine alpha plus 1 by root 2 cos alpha. So, that gives us what? Let me write it half over here and multiply this, so it is 1 by root 2. And this thing will give you sine alpha plus pi by 4, correct? Now, as alpha is lying between 0 and pi by 2, so alpha plus pi by 4, alpha plus pi by 4 will lie between what? Pi by 4 plus 3 pi by 4. Tell me yes or no. Correct? So, when alpha plus pi by 4 is lying between pi by 4 and 3 pi by 4, so you can say that sine of alpha plus pi by 4 will lie between what? Tell me first. It will lie between 1 by root 2 and 1. Yes or no? Because within this angle pi by 4 to 3 pi by 4, your sine will take any value between 1 by root 2 and 1. Okay, so if I multiply with 1 by root 2 in both sides, what we are going to have? Is it clear? Now let me add half on both sides. So in the left hand side we are going to have 1. This is half plus 1 by root 2 sine alpha plus pi by 4. which is again less than equals to half plus 1 by root 2. Is it clear? This is nothing but, this one is the area of the triangle ABC. Therefore, area of the triangle ABC is greater than 1 and less than equals to, this is basically what? 1 by root 2 is basically what? This is basically root 2 by 2. So simplification will give you 1 by root 2 divided by 2. Therefore, we have proved that the area of the triangle ABC is lying between 1 and 1 plus root 2 by 2. That's exactly what they have said in the question. Look at carefully. They have said, prove that the area of the triangle ABC is lying between 1 and 1 plus root 2 by 2. That's exactly what we have proved here. We have proved here that the area of the triangle is lying between 1 and 1 plus root 2 by 2. Hence proved. This one is a fantastic sum and a challenging sum at the same time. So that's all for this video. So see you in the next video. Till then, take care and goodbye.